Okay, in this tutorial we're looking at section 9.3 on the antiderivative of f of x equals 1 on x. Okay, we've got just a couple of nice little rules that we can use here, and then we'll get into some worked examples. So, if we need to integrate 1 on x dx, it becomes log to the base e of the modulus of x plus c, where x is larger than 0. Now you'll notice in the textbook they don't use the modulus sign. To be technical, it does, and those guys using specialists would be familiar with that, so we just need to be careful there that we're consistent. Okay, and if we're integrating 1 on a to the x plus b dx, that becomes 1 on a log to the base e, and that should be the modulus of ax plus b plus c, where x is greater than negative b on a. Okay, so again, to some worked examples, so we've just got those two rules that we can work with. Okay, so we've got worked example 4, which is we're going to find the integral of 3 on 2x with respect to x. So we're bringing our 3 out the front and make it 1 on 2x dx. Okay, so we can simply use our rule here. Okay, so we can say then that our coefficient of x, our a value, comes out the front over 1. So we have 3 outside of 1 on 2 log to the base e of the modulus of 2x plus c. Okay, multiply back through by our 3 and we get 3 on 2 log to the base e of the modulus of 2x plus c. Okay, and that's all we need to do for that one. Okay, for the next one we're finding the integral from 0 to 3 of 4 over 2x plus 1 dx. Again, we can bring our 4 out the front. So we're going from 0 to 3 of 1 over 2x plus 1 dx. Well, that's going to be 4 outside of. Okay, well, we've got to do our coefficient of x again. Okay, comes out over 1, so it's 1 over 2 log to the base e, okay, of our 2x plus 1 from 0 to 3. Okay, so we can bring our 4 back in at this point because it does work out nicely. 4 times a half gives us 2. So we're going to say we're 2 log to the base e of 2x plus 1 from 0 to 3. Okay, and now we can sub in our values and say that we're 2 log to the base e of 2 times 3 plus 1, okay, minus 2 log to the base e of the modulus of 2 times 0 plus 1. Okay, so that means that we're 2 log to the base e of 2 times 6 plus 1, 2 times 3 is 6 plus 1 gives us 7. Okay, it was positive, so we can just ditch our modular signs and just leave it as brackets now. Okay, if it was say 2 times 3 minus 8, then we would have had negative 2 and we would have needed to make it positive. Okay, and then we take away 2 log to the base e of 1. Okay, well, we can say, remember that log to the base e of 1 is 0, so it's simply 2 log to the base e of 7, or if you like, log to the base e of 7 squared, which is 49. Okay, either one of those answers would be fine. Okay, so we'll keep going. We've got a couple more worked examples to look at. So we look at worked example 5 here, and we're going to be solving a question via integration by recognition. So we need to differentiate y equals x squared on 4 times log to the base e of x, and hence find the integral of x log to the base e of x dx. So what we need to do is the product rule here. So we're going to say, well, g of x is equal to x squared on 4. Okay, h of x is equal to log to the base e of x. Okay, so g dash of x is going to be, well, it'll be 2x on 4, which will just be x on 2. Right, and h dash of x just becomes 1 on x. Okay, so we bring them together now and say, well, y dy dx, sorry, is equal to, well, we multiply across, so we've got x squared on 4 times by 1 on x plus x on 2 log to the base e of x. So our x and our x are going to cancel out, and we'll be left with x on 4, okay, plus x on 2 log to the base e of x. Okay, so what we can then say is if we integrate x on 4 plus x on 2 log to the base e of x with respect to x, well, that's going to equal what we start off with. So when we integrate our derivative, we get back to our original. Okay, so we'll get our x squared on 4 log to the base e of x. Okay, well, this doesn't look quite right yet. We need to actually make this look like what we've got up here. So we need to split it up and say that we've got our integral from of x on 4 dx plus our integral of x on 2 log to the base e of x dx equaling our x squared on 4 log to the base e of x. Okay, we can bring our half out the front, and so we've got the integral of x on 4 dx plus a half times the integral of x log to the base e of x dx, still equaling x squared on 4 log to the base e of x. Okay, and now we're simply going to start rearranging. Okay, so what we're going to do is we're going to bring this across, and then we're going to multiply by 2. So we're going to say our integral of x log to the base e of x dx is going to equal, we're going to multiply by 2, so we're going to say we've got 2 times x squared on 4 log to the base e of x minus 2 lots of the integral of x on 4 dx. Okay, so that means that we're going to have then that we've got x squared on 2 log to the base e of x, okay, minus the integral of x on 2 dx, okay, which means we're going to get x squared on 2 log to the base e of x minus, well, the integral of x squared of x on 2 is going to be x squared on 4. Okay, so we can say simply that the integral of x log to the base e of x dx is equal to our x squared on 2 log to the base e of x minus x squared on 4. Okay, and we're done with that worked example. So we've got one more worked example to go, okay, which is worked example 7 that we're going to do. We want find the area enclosed between the curve y equals 2 on x, the x-axis, and the lines x minus 3 and x minus 1. So if we were to draw a little graph of this, okay, our graph would look something like that. Okay, and we're finding our area from -1 to -3, so in this area here. Okay, so it means that we're going to be integrating, okay, from -3 to -1, and you see we're below the x-axis, so our area would end up being negative. So if we make it a negative out the front, okay, then we're not going to have any problems. Okay, and we're integrating 2 on x with respect to x. Okay, so what we're going to do here, okay, when we do the negative part, what that means is we can switch our terminals around and say then, so if we're saying that was the area, we can now say our area is equal to the integral of 1 to 3, okay, of 2 on x dx, okay, which is simply going to be 2 log to the base e of x, okay, from 1 to 3. Right, I'll come up here now, so we'll say that's 2 log to the base e of 3 minus 2 log to the base e of 1. Okay, well, log to the base e of 1 is equal to 0, so our area equals 2 log to the base e of 3. Okay, or we could say it's log to the base e of 9 by bringing our 2 up as a power. Okay, and then say, if you like, square units. Okay, now on an exam, you don't actually have to worry too much about writing square units. You do need your units, however, if units are given. Okay, so if we're finding our area in square metres, well, we know that we need to put square metres at the end. No units are given, then there's not really an expectation that you put the units on. Okay, so that's all we have for this worked example. So hopefully you got okay with the questions.